is what you get out. This is a snapshot of a collision. This is an actual Higgs boson. You probably have heard in the media when this was finally discovered. This was searched for over 30 years. We are following the protons now, and in the middle, in the center of the detectors, the two protons from the two sides will meet right in the center. Actually, for two protons colliding, we get about 100 new particles, and that's what we are studying, actually. It's these secondary particles out of the collisions of the protons. The collisions take place every 25 nanoseconds, so it is no way that there's any kind of human intervention into this. So this has to be completely autonomous systems. And the sensors, the millions of sensor elements which make the detector are spread out over a very large volume. So if you want a computer algorithm to run on the collision data, you have to bring the data from all these sensors into a single place, into a single server. So that is done by means of a switching network. So we use large switching networks which are larger than the largest telecom networks, actually. What we store, this is what is giving nightmares to my colleagues at the physics analysis. So if you ask these people, they will tell you that you should not throw away anything. You should take the detector, you should buy a lot of tape silos, and you should just store everything, just in case.
What is stream processing? We can have a data stream coming into in-memory processes that are performing continuous queries on the information and spitting out alerts, statistics, and filtered output. All the historical data, we can aggregate it and then apply the learnings back to the stream to change the decision boundaries, to change the models over time. This is where machine learning comes in. So, basically techniques for learning from data when a pattern exists and we don't have a mathematical description, because if we had a mathematical description, we would just write it down and be done with the problem. But the good news is, if you tune the system using machine learning, then you'll be able to you'll be able to detect very small signal differences. So when there is a fault injected in the engine to test this system, that little minute difference between the trained model and the actual engine output gives us a big signal. And that's how we accomplish better monitoring of the aircraft system using machine learning. So we'll treat it as a black box. And the question is, if we had thousands of engines and tens of thousands of hours of flight data, could we make good predictions out of a black box like this, given measurements across the fleet and faults that we want to detect?
This is the blueprint that we've been working with the Bosch team. So where do you start? You've seen it's a challenging topic. How do you analyze this data easily? How do you identify your patterns? How do you build these applications in real time? So we are launching a new tooling for our platform. It's called the Stream Explorer. And the goal is to really simplify the complexity of this domain by giving the data to you in a business format.
The strength of a document store like MongoDB lies, in addition to the scalability and the flexibility of the kind of data that we can store. So if I go into the difference between a relational model and a document model, then in a relational world, what we're used to is to normalize data, which makes sense. These technologies have been invented in the early 1970s when disk space was very expensive. And we normalize data by spreading data over multiple tables. And when we do a query, we join this data back together. In a document store, we don't do that at all. What we do is we embed data into documents with the emphasis on the usage of the data. Another way of looking at it is this way. If you would store your car in the relational world in a parking lot, you would completely take it apart, put all the parts on the shelves, so very efficient for storage. You want to drive your car out again, you reassemble the car and you drive it out. In MongoDB, you drive your car in and you drive your car out again. Much less efficient for storage, much more efficient for usage. And that's how we get our performance.
Now, at Rexroth, we've built up the following system. We start at the machine where we install the sensors, we collect it, and we use a data acquisition system on site which collects the data. These machines are often in remote locations, talking about offshore applications or mines. We transmit this data
to a remote big data storage system and regularly write status reports to the customers where we then put in recommendations which maintenance activities are to be done. We have successfully adopted these methods for anomaly detection in the first pilot cases. And what we are targeting with this service are applications with very high downtime costs.
What we're doing in NIME is we're building an open platform that allows you to very versatile access to various data sources, combine them, mesh them, blend them, and also throw different types of techniques at these in a very easy, intuitive way, so that it's not only usable by a specialist, but it's also something that you can give to someone who may not be able to really build up that application, this analytics workflow from scratch, but may only want to use that as a template. Then, of course, I mean, what we hear about today's Internet of Things and Internet of Things is, from our perspective, a bit more. It's, of course, also all these wearables. Who here has a smartwatch? It's about social media analytics, right? There's tons of data out there that helps you understand your customers a bit better. And then, of course, I mean, all of you have probably seen this. Bosch Software Innovations and NIME are partnering to bring advanced analytics to this type of Internet of Things that we're talking about here, right? Procter & Gamble here for retail store analytics, which is very interesting. It's the Consumers Report in England. They're building every night, thousands of models and are doing price predictions. So if you go to their website, you can actually look at consumer reports for a product, and then they tell you, is it likely that the price will go up, or should you wait a bit longer because the price will actually go down? Pretty neat.